Hello, my name is Francis Uwejo, and this is my Physics 2212 Lab 3 bar magnets. So the goal for this lab was to explore the existence of a correlation between a magnetic field and observable distance. We also wanted to create a computational model of magnetic fields using glow script. The main results that I found are my n value of approximately minus 3.3. Some of the important physics concepts that were explored in this lab were the Biot-Savart law and bar magnets you can see here. For the on-axis component of the experimental observation, the system was a magnet and the surroundings was the meter stick, phone, and table. The procedure for this component of the lab included determining the direction of the magnetic north, setting up the meter stick so that it was orthogonal to north, and moving the phone at various distances along the meter stick and as well as at a 45-degree angle. Here's one of the data collected during this component of the lab. And here's a graph that shows linear regression from this data. The experimental observation for the off-axis component of this lab included positioning the phone at D underscore perp, a descent perpendicular position in both the X and Y directions. As you can see on the left, the diagram what this looks like. Then we measured the magnetic field using the magnetometer app. The results was an average D perp of 0.173 meters and an average magnitude of B of 1.76 times 10 to the negative 4. Here you can see some of the spreadsheets that I used to collect data. First computational model compared the predicted magnitude of the B value to off-axis estimates. Here you can see the measured versus the computed values, and on the right you can see some of the computational modeling that went into this component of the lab. Here's the second computational model, which was the magnetic field. On the right, you can see the code that was involved in this part, and on the left here you can see what the rendering looks like in GlowScript. Some of the assumptions for this lab were that the magnetometer is accurate in its readings and that the magnet length is minimal. Some of the sources of error were possibly inaccurate measurement of distances moved on the meter stick, errors with the use of the magnetometer app, as well as errors in any of the calculations made. What if questions? What if you hadn't oriented your experiment to compensate for magnetic north? My observations from the magnetometer readings would skew towards the magnetic north either way, but my calculated values would be more inaccurate in this case. And what if you were to stick two identical magnets together end to end and run the experiment again? In this case, the direction of the magnetic field would not change. However, the magnitude of the magnetic field would theoretically double. Thank you for your time.